present about the halogen groups. Halogen groups located at the most right of the periodic table. This is the group 7, which is fluorine, chlorine, bromine, iodine. All of the halogen except for astatine are obtained by the oxidation of halide ion. Oxidation means the loss of the electron. Astatine not easy to lose the electron because it is highly radioactive element and it is artificially made. And the order increase is of the oxidation for halogen is increased down the group. So we go to the first element of the halogens, which is fluorine. Fluorine common ores are naturally found in the fluoride or chloride or fluoroapatite. And fluorine production is based on the electrolysis of KHF2, and this electrolysis is undergo in anhydrous condition. So the second element is chlorine. Chlorine common ores can be found in the sodium chloride, potassium chloride, magnesium chloride, and calcium chloride in salt water. And this chlorine can be produced industrially by electrolysis of the concentration aqueous NaOH solution, and also they can be made in the lab by oxidation of hydrochloric by manganese oxide. Bromine occurs mainly in bromides of the sodium, potassium, magnesium, and calcium in salt water, and also underground brines or salt bed. The production of the bromine can be treated of the hot brine with chlorine. And last but not least is iodine. Iodine can be found in the dried seaweed or from the NaIO3 impurities. And the production of iodine can be obtained from the reduction of iodine ions with hydrogen sulfide ions.
Okay, next we proceed with the reaction of free halogens. The general reaction is between halogens with metals, as you can see here, and free halogens also can react with group 5 elements, which will produce trihalides, this one, and also it will produce pentahalides, this one. And also free halogens can react with hydrogen sulfide, which will produce a free sulfur and also hydrogen halide. And it also will displace the halides of a less reactive halogen like this one, like iodine, and it is lower down in the periodic table, for example, like bromine and also iodine. It will produce two bromine and iodine solid.
Hydrogen halides and hydrohalic acids. So what is hydrogen halides and hydrohalic acids actually? Hydrogen halides is a colorless gas with a very sharp and sting odors. So when they dissolve in water, they will form a hydrohalic acid. There are several ways to prepare hydrogen halides. The first way is by direct combination of hydrogen and the halides. So this is the general reaction to prepare hydrogen halides. We take a simple example, which is hydrogen halides react with Cl2 and you will get 2 mole of hydrogen chloride. The next step to produce hydrogen halide is by reacting metal halides with non-volatile acids such as concentrated sulfuric acids or concentrated phosphoric acids. So we get the examples, which is potassium bromide react with H3PO4, and then you will get a monopotassium phosphate, which is KH2PO4, and you will get your hydrogen bromide. For the acid strength in the halogen group, by going down the group, the acid strength will increase, and you will notice that hydrogen fluoride is the most weak acid. This is because fluorine is the most electronegative element very polar bond with the hydrogen, so they are very hard to dissociate. Compared to the iodide, iodide is the less electronegative element in the halogen group, and they will form a less polar bond with the hydrogen, so it is easier to dissociate. That's all. Thank you.
So this is the general formula of oxoacids, which is also known as ternary acids, and they are divided into four, which are HXO, HXO2, HXO3, and last but not least, HXO4. And as you can see, there are 3 points under one type of oxoacids, which are the oxidation number, the electronic geometry, and last but not least, the molecular geometry of each of the structure. The reaction in oxoacids of the halogen, firstly, the formation of aqueous hypohalous acid, and the second one, hypochlorous acid that decompose into hydrogen chloride and oxygen radical. The third one is the reaction of halogens with co-dilute bases that lead to the formation of hypohalite salts. And the fourth one, hypohalite ions that disproportion into halate and halide ions. The fifth one, treating of barium chlorate with sulfuric acid that leads to the formation of aqueous chloric acid. And the sixth one, the reaction of free halogen with hot aqueous alkali that lead to the formation of halate. And last but not least, the decomposition of halates with catalyst and also without the catalyst.